we want to talk about gas laws. And you see, gas law deals with behavior of gases. So if I'm talking about gas laws, I'm going to trace it down to what the kinetic theory state about gases. Because kinetic theory of gases state that gases are constantly in motion. And because the gases are constantly in motion, it means that there are procedures, there are factors that determine the movement of these gases. And these movements and these factors depends on the volume, pressure, and temperature, kind of temperature of the gases, because this determines their movement, determines their fill up, and that is that. Now, if I'm talking about gases, this one is just telling us about behavior of gases in terms of movement, in terms of what gases can do, and all that. And we have some scientists that have given some laws on the behavior of gases. And the first one here is what the Boyle's law. The Boyle's law. Then we have Charles' law. We have the Charles' law. Then we have the general gas equation. The general gas equation or the general gas law. Then we have the ideal gas law. Ideal gas law. Then we have the Graham's law of diffusion. Graham's law of diffusion. Then we still have Gay-Lussac's law. We have Gay-Lussac's law. And then also we have the Avogadro's law. Avogadro's law. So all these are laws which we are going to be considering under the gas law. So we have what the Boyle's law, we have the Charles law, we have the general gas equation, we have the ideal gas law, we have Graham's law of diffusion, we have Gay-Lussac's law, and we have the Avogadro's law. So these are one after the other that we're going to be looking at all these things under the gas law. Now let us look at the first one. I want to look at the first one under all these laws. Then we have to look at the Boyle's law. The Boyle's law, Boyles is a scientist that tells us that there is always a relationship between volume and pressure when the temperature is constant. It means that when gases are behaving or there's a movement in terms of compression, in terms of anything you want to do, but in terms of movement of the gases, then Boyles is telling us that temperature is constant. And what did he state? Boyle's law states that at constant temperature, the volume of a fixed mass of gas is inversely proportional to the pressure. Inversely proportional to the pressure. So the Boyle's law is telling us that when we have this inversely proportional to the what? To the pressure. This is what Boyle's law. Boyle is telling us that, and there's an interpretation to this, but let us put a constant. We have what is equal to what? K over P. And so we have so here we'll be adding Vp equals to K. So when we have them volume 1, volume 2 in two ways, we have what? V1 P1 equals to what? V2 P2. And this is the Boyle's law. Just this, state the Boyle's law. This is the expression of the Boyle's law, and this is what the mathematical interpretation of the Boyle's law. That is what Boyle is telling us, that at constant temperature, you can also define it that the volume of a fixed mass of gas is inversely proportional to the pressure when the temperature is kept constant. So here, even in the formula, we cannot see the temperature here. And there's something I want to chip in here. And another explanation of the Boyle's law. The Boyle's law is telling us that from this formula, Vp, it means that as the volume increases, yes, look at the formula, look at the interpretation of this. It means that when the volume increases, the what? The pressure also increases. Pressure also what? Increases. Then of the Boyle's law, it shows that as the volume increases, the pressure also what? Increase. That is, like for example, in the case of a syringe, you will see that in the syringe, when you try to push up the plunger, you will see that you need to exert more force. And if you are exerting more force, what happens? Then the volume also does what? The volume, you are trying to push up, like if somebody is trying to force, so you are exerting more force. And moreover, the more volume, the more liquid inside the syringe, the more pressure you are going to apply. So that is the idea of the law. Then putting it in a graph, you have a volume. Let's say this is a line. This is a graph that passes through the origin. That is, you have volume and the pressure. So when you plot a graph of volume and the pressure, it is what? Inverse, and it passes through the origin. And that's the Boyle's law. Then what about kinetic explanation of the Boyle's law? The kinetic is trying to tell us that at constant temperature, when the temperature of a gas or in or a situation or a gas cylinder or an environment is constant, what happens? They believe that when the temperature is constant, then the volume of the gas particles, the particles have more kinetic energy to move around. So it also what? The volume also, so the particles have a way of moving around faster, you understand? But also, which means that because we are not talking about temperature, because we are not talking about temperature here. So okay, let us look at kinetic explanation of the Boyle's law. Kinetic is telling us that when you exert more pressure, if you exert more pressure or something, then the more volume you have. Just like I've used a syringe and I've used a tire. If you are trying to pump a tire, okay, in fact, the tire is an example. Bicycle tire is a very good example using a kinetic concept, a kinetic theory to explain the Boyle's law. Now, if you want to pump a tire, then you exert more force. And exerting more force, the particles have more, they collide with each other, and it brings up more volume. So it means that if I'm trying to pump a tire, if I take it to the vulcanizer, what happens is that I'm going to pressurize the tire, then put in more volume. So the volume and the pressure increases. As the volume increases, the pressure increases. The pressure increases, the volume increases. That is the Boyle's law. Then what about the mathematical aspect of the Boyle's law? We have what? We have P1 equals to what? P2 V2. And mind you, in IGCSE, Neco, Jamb, all of them have what I've seen based on my experience is that I've seen them have different in terms of unit. Like for example, let us look at volume. Volume for Waec is usually cm3, then or dm3, or probably yes, volume cm3. When I see questions, usually cm3 or dm3. But if I'm talking about Jamb now, for volume, usually by liter. They use liter, maybe like half a liter, 0.5 liter, and all that. And you should know that 1000 cm3 equals to what? 1 dm3. So which I'm going to use an example to explain that, and that is that. Then the next one here is what? The pressure. What about the unit of a pressure? For Waec standard, majorly millimeter mercury. When I have a millimeter mercury, that's the pressure. Then millimeter mercury equals to what? I mean, we have millimeter mercury, then we have ATM, and we have PA, that's the Pascal, and we have what? kPa. So 1000 PA equals what? 1 kPa in some questions. That's just. Then we have 760 mmHg of millimeter mercury equals to what? 1 atm. Yes, 1 atm. And we also have what? We also have one of pressure, that's or 101.325.323 in terms of pressure. So we can also make it of atmospheric pressure and all that. So these are the things we are going to look at. Now let me give an example. I'm going to give an example so I can explain all these things using an example of the Boyle's law. So I'm going to give like 2 examples on the Boyle's law. Let's look at, if you have what? 100 cm3 of a certain gas at 760 mmHg was compressed. Find the Find the volume. Find the volume if the pressure was raised to 800 mmHg. Now, if you are still looking at this, of course, when you are treating Waec question or Jamb questions, nobody will ask you that this is Boyle's law, Charles' law. They just give you a question. Then you can actually get to solve this one based on the parameters you are given. Now, what are the parameters here? You look at, I told you that volume is in cm3, and I told you our pressure is in mmHg. So we are going to write out our parameter. We have the first volume that was mentioned was volume is what, 100 cm3. That's 100 cm3. Then this first pressure was what, 760 mmHg. Then from the question, find the volume. So our V2 equals to what? Question mark or unknown. Then when the pressure was raised to, so this one is P2. P2 equals to what? 800 mmHg. So doing this, we have interpreted, we have our parameters. They can now say what? I can say P1 V1 equals to what? P2 V2. So what's my V1 here? P1 I have what? 760 times 100 equals to, I'm looking for V2, that's 800 V2. Can you get that? So that's, we have V2 equals to what? 760 100 this over 800. Did you get that? What did I do? Divide both sides. Okay, let's make it clear. So I can get my V2 from here. So I just divide both sides by what? 800 by what? 800. So I have this goes. So I have what? V2 equals to what? 760 times 100 over 800. So V2 equals to. So you can see this is an interpretation. I'm just going to give you an example on this. Yes. Have you seen that? So let's continue from here. So we have 760 times 100, that's 76,000, then we have 800. So we have, so dividing that, we have 95. And be mindful of the unit. Because we are looking at volume, that second volume. Volume in the question is what? Centimeter cube. So that is that. So if we are talking about Boyle's law, we talk about V1, P1, because what? V2, P2. Is that you are giving this? Look, is that you are giving this, you are giving this, look for this, or you are giving this, you are giving this, you are giving this, look for this. So whatever, just find a way of looking at the parameters. And in some questions you see at constant temperature, and in other questions you might not see at constant temperature. You just see that you will just be giving the parameters. But majorly from Waec will give you Waec, Neco, they will put always at constant temperature. Yeah, but I've seen some IGCSE question and they don't put at constant temperature, they only put the question straight. So that's to test your knowledge or your ability to. That's your ability to understand that, oh, this is Boyle's law. How do I get that? I just know that through the parameters I'm giving, and that is all about the Boyle's law. So let me quickly give another example and you see. Yeah, example 2. It is an example 2. Then we have 200 cm3 of a gas was compressed at 800 mmHg of pressure. What will be the pressure? What will be the pressure if the volume was raised to 400 cm3? You can see this. 200 cm3 of a gas did not put at constant temperature or at anything. Normally it's supposed to be at constant temperature, but in a standard question you see. So what do? You just write out the parameters. You have V1 equals to 200 centimeter cube. Then another pressure here, P1 equals to 800 millimeter mmHg. Then what we have next is what? V2 equals to 400 centimeter cube. Then what is P2? P2 is what we are looking for. So we have what? P1 V1 equals to what? P2 V2. So what do we have? We have 800 times 200 equals to what? That's 400 P2. So P2 equals to what? 800 times 200 over 400. And let us try to bring this out. So we have 16,000. That's 160. Then over 400. So we have this go this two, then 160. Then we have what? 1600. That's 400 millimeter mercury. So do we confirm that?